Okay, OpenGL it is. Alright. Okay, so what are we doing right now? Now the idea is I want to learn about graphics programming, but I am new to it, and the challenge is I've never done graphics programming before, although I am a UI developer in my day job. And just to learn more about graphics programming, I wanted to log this work so that maybe it also helps other people. Now the other thing which I want is to not use Visual Studio as my primary IDE, because I am one Neovim in Java evangelist. What word did I say? It should have been evangelist. So I ended up creating a workflow where I can write C++ code, and with the help of CMake, I'm able to run. I'm able to, let's say, make this. Okay, failed to initialize glad. Something went wrong. I think I broke it. Let's figure it out. Let's figure it out if we can actually fix that. So the idea should be is all right. So what am I even doing right now? See, I don't know OpenGL. It's my I've just done these three uh, tutorial windows, nothing more than that. I tried to do hello triangle, but I ended up because there's just so much stuff you need to first understand before you're able to even write code for shaders. Okay, and I think this is by design, but I don't know. I don't know. We'll see. We'll see. We'll see how it goes. So I also wrote a script where whenever I change any um, C++ or header files, it will automatically rerun or rebuild, but the exact running process is something which I still need to do. So failed to initialize that. There is some error which I am getting, which I'm not able to figure out what. Hmm. Unsigned end vertex shader. Okay, okay. So, huh. See, I think somewhere I'm. Okay, let me check what was my last commit. Hmm. Alright, so this was the most stable code which I had earlier. Huh. There you see. There you go. You see a simple window. Just to get this part, it took me so much time, almost a week, uh, to just like figure out how do I open a window on Microsoft Windows using OpenGL, or let's say all the abstractions which they've defined. Let's see, how it goes. So I'll also give a short overview of what am I trying to do. See, these are my compilation flags, and I'm also using like some code quality things so that at my end I don't end up shooting myself in the foot. And the syntax is supposed to be modern, as if like C++ modern. That is, you will just enjoy every bit of it. Now this setup is not perfect, but it works for me, and that is all I actually care. So okay. exe failed, etc. I'm not sure. See, it's just printing the logs. And OpenGL hello. And my first window should be, wait, what is this though? OpenGL.exe ld return 1. Huh. collect2.txt ld return 1. What is ld? Permission denied. Cannot open output file. What? So this is what happens when you try to do everything by yourself. Anyways, let me see. Why do I? Okay, now it works. So apparently you cannot build it if. Okay, I see it. Oh, see, what was happening before is that because I already had a pre-built binary which I was executing. Windows has this thing where if you're using something, if you're using some version of the program, you cannot just kill it. That is, you have to follow the Windows rules where you have to close the window first and then try to maybe copy, read, etc. write it back. Anyways, so I'm trying to understand what the entire idea of shaders are, and currently so far I'm able to do this where I'm just rendering a small window. Alright, so let's just read through it and figure out OpenGL. Now here we will try to do hello triangle. Now in OpenGL everything is in 3D space, but the screen or window is a 2D arrow pixels. So a large part of OpenGL work is about transforming all 3D coordinates to 2D pixels that fit on your screen. The process of transforming 3D coordinates to 2D pixels is managed by the graphics pipeline of OpenGL. The graphics pipeline can be divided into two large parts. The first transforms your 3D coordinates into 2D coordinates, and the second part transforms the 2D coordinates into the actual color pixels. So this chapter will briefly discuss the graphics pipeline and how we can use it to our advantage to create fancy pixels. Now see, I'm reading this again. I read this before, but earlier I was not able to get the entire idea of how it actually really works, because see, I am a person who likes to do things first, and if they work, then I'm able to traverse back and get the theory. If you just show me the theory before, it is just information to me and that just goes above my head. Like I get some little bits of it, but it's the process of redoing things which will actually make you understand stuff. Like this is just something which happens to me. Alright, so the graphic pipelines takes as input a set of 3D coordinates and transforms these colored 2D pixels on your screen. The graphics pipeline can be divided into several steps where each step requires the output of the previous step as its input. All of these steps are highly specialized. They have one specific function and can be easily executed in parallel. Because of their parallel nature, graphic cards of today have thousands of small processing cores to quickly process the data in the graphics pipeline. The process cores can run small programs on the GPU for each step of the pipeline. These small programs are called shaders. Shader. Okay. See, it took me so long to just get to this word. Shader is actually amazing. Some of these shaders are configurable by the developer, which allow us to write our own shader to replace the existing default shaders. That's cool. This gives us much more This gives us much more fine-grained control over specific parts of the pipeline, and because they run on the GPU, they can also save us valuable CPU time. Shaders are written in OpenGL shading language GLSL, and we'll delve more into that in the next chapter. Okay, so below you'll find an abstract representation of the stages of the graphics pipeline. Note that the blue sections represent sections where we can inject our own shaders. Alright, so you have vertex shader, you have like vertex data, and then geometry shader, and then shape assembly, rasterization, fragment shader, and tests and blend. Okay, I understand none of it. As you can see, the pipeline contains a large number of sections that each can handle one specific part of converting your vertex data to a fully rendered pixel. We will briefly explain each part of the pipeline in the simplified way to give you a good overview of how the pipeline operates. As input to the graphics pipeline, we pass in a list of 3D coordinates that should form a triangle in an array here called vertex data. Okay, these vertex data is a collection of vertices. A vertex is a collection of data per 3D coordinate. So it's just a coordinate, a physical 3D coordinate. This vertex data is represented using vertex attributes that can contain any data we like, but for simplicity's sake, let's assume that each vertex consists of just a 3D position and some color value. In order for OpenGL to know what to make of your collection of coordinates and color values, OpenGL requires you to hint what kind of render types you want from the data. Do we want the data to be rendered as a collection of points, a collection of triangles, or perhaps just one long line? These hints are called primitives and are given to OpenGL while calling any of the drawing commands. Some of these hints are GL points, GL triangles, and GL strip. The first part of the pipeline is the vertex shader that takes as input a single vertex. First part of the pipeline is the vertex shader that takes as input a single vertex. The main purpose of the vertex shader is to transform 3D coordinates into 3D different coordinates. 3D coordinates into different 3D coordinates. More on that later. Okay, absolutely, because I need to know. Alright. Okay. I got it. I think you could have just said normalization, because you can have coordinates in I mean, the domain of your coordinates can go from negative n to positive n, but you actually map it to -1 and +1. That's exactly what normalization is. More on that later. Okay, so see, okay, one more thing. I'm good at math. I spent a lot of time in my high school years understanding a lot of mathematics, and this is where I get to apply it. So it's really cool. Anyways, and the vertex shader allows us to do the same basic processing of the vertex attributes. The output of the vertex shader stage is optionally passed to the geometry shader. The geometry shader takes as an input a collection of vertices that form a primitive and has an ability to generate other shapes by emitting new vertices to form new primitives or other primitives. Generates a second triangle out of the given shape. Okay, the primitive assembly stage takes as input all the vertices or vertex if GL points is chosen from the vertex shader that form one or more primitives and assembles all the points in the primitive shape given. In this case, two triangles. The output of the primitive assembly stage is then passed onto the rasterization stage, where it maps the resulting primitives to the corresponding pixels on the final screen, resulting in the fragments for the fragment shader to use. Before that fragment shaders run, clipping is performed. What is clipping? Discards all the fragments that are outside your so increasing for okay, I mean that's actually good. I didn't know like there existed a term for it, so why don't I notes and date dot let me write some notes. What do I say? What am I learning even? Hello triangle. I think I can increase the font size if somebody actually wants to view what am I doing. Alright, what now? So okay, let's give myself 30 minutes on this. Oh, so this is one piece of code which I wrote, which gives me a timer. I mean, my cheap way of doing Pomodoro, but yeah, it works for me. Anyways, so the output of the vertex shader is optional. Okay, I read that. In this case, two triangles. Okay, the output of the primitive assembly stage is then passed onto the. Alright, I also read that. Can I just write it down, all of this? Although I really want to. Let me. So see, this is how I take notes. I mean, if an Emacs user is watching, like, they would say, just use org mode. Why are you not using org mode? Because I don't like it. Because I have skill issues. I tried to learn Emacs, but I was so Neovim build that I ended up not caring a lot about H1s looking like in their original size. Okay, see, okay, so this is still out of. Alright, this I think is the best way I can do it. I can keep it till here. Okay. Okay, nothing. Your editor is not this fast. Don't kid me. Okay. Your VS Code or your Visual Studio can never be this fast. I'm running it inside Western, and everything you can do on your Visual Studio mess, I can do it here. This is freedom. Neovim gives you freedom. Okay, I'll keep on ranting about Neovim in between because this is just how I do stuff. Anyways, a fragment in OpenGL is all the data required for OpenGL to render a single pixel. Makes sense. The main purpose of the fragment shader is to calculate the final color of pixel, and then this is usually the stage where all the advanced OpenGL effects occur. Usually the fragment shader consists data about the 3D scene that it can use to calculate the final pixel cover, like lights, shadows, colors of the light, and so on. After all the corresponding color values have been determined, the final object will then pass through one more stage that we call the alpha test and the blending stage. Okay, so see, I did read the source code beforehand, and this is what I will suggest to somebody who is trying to learn OpenGL as well. If you're learning OpenGL from this website, at least go through the source code which this website is attaching at the end of the section, then try to understand what is written. Because see, I don't know, like, some people just get it, but I like to see the final result first and then work my way back from the starting point. Hope it makes sense. Anyways, after all the corresponding color values have been determined, the final object will then pass through one more stage we call the alpha test and the blending stage. This stage checks the corresponding depth and the stencil value. We'll get to those later. Okay, the other thing we'll get to those of the fragment and uses those to check if the resulting fragment is in front or behind other objects, or it should be discarded accordingly. The stage also checks for alpha values and blends. Alpha value is the opacity value, and blends the objects accordingly. So even if a pixel output color is calculated in the fragment shader, the final pixel color could still be something entirely different when blending multiple triangles. That makes a lot of sense, because if you have a light source, see, I have not written a single, see, still now I've not rendered a single triangle. I'm just imagining, because from a 2D window, if you're looking through a scene, how can you simulate it? And I believe, like, this is the best way you can do it. Okay, let's just move on. How much time do I have? 25 minutes, is it? Okay. The stage. Okay, where was I? So even if a pixel output color, okay, I read that. As you can see, the graphics pipeline is quite complex and contains many configurable parts. However, for almost all the cases, we only have to work with the vertex and the fragment shader. The geometry shader is optional and usually left to its default shader. There is also the tessellation stage and transform feedback loop that we haven't depicted here. but that's something for later. In modern OpenGL, we are also required to define at least a vertex and a fragment shader. Okay, of our own, there are no default vertex fragment shader on the GPU. For this reason, it's quite difficult to start learning modern OpenGL since a great deal of knowledge is required before being able to render your first triangle. Once you do get to finally render your triangle at the end of this chapter, you'll end up knowing a lot more about graphics programming. And this was so daunting, but then I really like how he, the author, I mean, I really like how he writes it. Okay, this is just a reference which I like to create because I end up reading stuff again. So yeah, see, if any one of you says that I don't have a working LSP working, there you go. Still, it's impressive, right? I can do it in Neovim. Anyways, vertex input. To start drawing something, we'll have to first give OpenGL some input vertex data. Okay, let me write it down because I think it would make more sense if I just because see, this is a lot of information that I need to keep a track of. OpenGL is a 3D graphics library, so all coordinates that we specify in OpenGL are in 3 dimensions. OpenGL doesn't simply transform all your 3D coordinates into 2D pixels on your screen. OpenGL only processes 3D coordinates when they are in specific range. You could have just said that you need normalization. You need normalized 3D coordinates. All coordinates within this is so-called normalized device coordinates. Okay, that's the actual definition. It comes from math. The process of normalization is mapping something, mapping a vector to its unit length is what normalization is. I mean, this I see so many math references. My back hurts. All the coordinates outside this region board because we want to render a single triangle, we want to specify a total of 3 vertices with each vertex having a 3D position. We define them in normalized device conditions, coordinates, the visible region of origin in a float array. Vertices. And I hate C++ syntax, but because OpenGL works in 3D space, we need to render a 2D triangle with each vertex having a z coordinate. This is the depth of the triangle remains the same, making it look like 2D. Okay, so you are not really. I mean, see, this is like nerfing it because see, what would be my project? I want to simulate a black hole. I want to do physics simulations using OpenGL, and I want to write all of that code by myself. Quite interesting though. I see, because it makes absolute sense. If you make a framework based upon 2 dimensions and try to extend it, it would be way more difficult. So just, I mean, they were thinking like actual physicists or mathematicians, because a sphere's 2-dimensional projection is a circle, or a trapezium, so you can say quadrilaterals. There exists like some quadrilateral whose projection will be a triangle on a 2D screen. So I mean, this is how you get vector algebra anyways. I shouldn't call it vector algebra, just when you take a dot product, the dot product gives you the projection of it. So I mean, it's great. I get to apply it. I mean, I'm a math nerd, and this is just good stuff for me. Alright, normalized device coordinates. Once the vertex coordinates have been processed and in the vertex shader, they should be in the normalized device coordinates, which is a small space where xyz values vary from -1 to 1. Any coordinates that fall outside this range will be discarded, clipped in, and won't be visible on your screen. Hmm. Below you can see a triangle where we specified within anomalous device coordinate, including the z-axis. Alright, that's fine. That's cool. Unlike usual screen coordinates, the positive y-axis point in the up direction and then the center of the earth instead of the top left. Eventually, you would want all the transform coordinates to end up in the coordinate space, otherwise they won't be available. Okay, this is an important point though, because if you've done any web development, you will end up knowing that the top left is your usual origin of the screen, and the bottom right is your actual height and width. Wait, this Windows taskbar is annoying me. I won't automatically hide the taskbar. Yeah, somebody who is like trying to see these videos should be watching it like nicely. Okay, 18 more minutes. Let's try to finish this. Your normalized NDC normalized device coordinates will be then transformed into the screen space coordinates by the viewport view. Oh my god, actually using data provided with the GL viewport. This results transformed into the resulting screen space coordinates are then transformed into fragments as inputs to your fragment shader. Makes sense. I mean, see, all of this is like very logical, but I still need examples, proper examples, so that I see them working. With the vertex data defined, we'd like to send it as input to the first process of the graphics pipeline, the vertex shader. This is done by creating memory on the GPU where we store the vertex data, configure how OpenGL should interpret the memory, and specify how to send the data to the graphics card. The vertex shader then processes as much vertices as we will tell it to from its memory. We manage this memory via so-called VBO. Okay, this stuff is important as hell. We manage this memory via so-called vertex buffer objects that can store a large number of vertices in the GPU's memory. The advantage of using those buffer objects is that we can send large batches of data all at once to the graphics card and keep it there if enough memory is left, without having to send data one vertex at a time. Sending data to the graphics card from the CPU is always relatively slow. So wherever we try to send as much as data as possible at once. Once the data is in the graphics card memory, the vertex shader has almost instant access to the vertices, making it extremely fast. I mean, locality. There is a word in like computer science for it. Locality of cache. I'm not sure. But like something exists. There is one word for it. I can't really remember it. But yeah. But I get what is the issue. A vertex buffer object is our first occurrence of an OpenGL object, as we discussed in the OpenGL chapter. A vertex buffer object is our first occurrence of an OpenGL object. I don't remember. GLGen buffers. Do I have anything? I don't have any code. I mean, what the author was referencing, I thought I have written it before, but no. A VBO is our first occurrence of an OpenGL object we've discussed. Just like any object in OpenGL, this buffer has a unique ID corresponding to that buffer, so we can generate one with a buffer ID using the GLGen buffer function. Okay, let me write it down. I should do it. The more I write, the better it exists in my muscle memory. CPP. See, you can do this in Neovim. Although these block of codes unsigned unsigned int, what is it, VBO, and then glgen buffers 1 and then VBO pointer to that unsigned integer. Alright. Interesting. Anyways, OpenGL has many types of buffers object. OpenGL has many types of buffer objects, and the buffer type of a vertex buffer object is GL array buffer. Okay, and OpenGL allows us to bind to several buffers at once. Buffer type of a buffer object is GL array buffer. Such a bad abstraction, but it's like what we are talking. I mean, 2005 C++ or 2001 C++. I was like 2 years old at that point. OpenGL allows us to bind several buffers at once as long as they have a different buffer type. We can bind the newly created buffer to the GL array buffer target with the GL bind buffer function. Okay, so what they're saying that there are many types of buffer objects, and the buffer type of a vertex buffer object is GL array buffer, and then OpenGL allows us to bind several buffers at once as long as they have a different buffer type. So different buffer type. So I mean, does this value has to be changed for another video? The newly created buffer. We can bind the newly created buffer to the target with the GL bind function. All right. I mean, that's okay. I don't like really understand the entirety of it, but it's fine. I can take this stuff just as pure information. Wait, this block of code should have, okay, I think backtick is missing. What? So OpenGL has many types of buffer objects, and the buffer type of a vertex buffer object is GL array buffer. Alright, CPP, GL bind buffer, and then GL array buffer, and then VBO. Okay, see, one way to identify if somebody has written code from maybe an LLM is to check for white spaces. Because I don't know why, but LLM generated code is just so visual. It's just so obvious when you look at it. Okay, OpenGL allows us to bind to several buffers at once. From that point on, any buffer calls we make on the GL array buffer will be used to configure the currently bound buffer, which is BVBO. Then we can make all to GL buffer data function that copies the previously defined vertex data into the buffer's memory. Oh my god, so it has like 3 steps. First you, okay, let's just write it down. Can I play non-copyright music in the background? Maybe. Is there a way I can do that? Non-copyright music. play for streams. Is there a way I can do that? NCS non-mainstream, no ban stream. Discord. Don't tell me it is paid. Uplifting synthwave. Okay, this looks nice. Can I play it just by clicking on it? Oh my god. I think I can share some of the desktop audio. Hello. Maybe something is wrong, but that not that good. Advanced audio properties. Is there any way? Okay, I forgot. How do I let it be the way it is. We'll turn off the, I think something is messing with OBS. Well, I'll figure it out later. For the time being, maybe no music. Okay, so from that point on any buffer calls we make on the GL array buffer tag, we'll be used to configure the currently bound buffer, which is VBO. Then we can make a call to the GL buffer data function that copies the previously defined vertex data into buffer's memory. GL buffer data. Okay, so there are 3 steps to it. First, you had to create a VBO, and then you bind it. Then you bind to it. Then you okay. So see how it goes is. First you define your VBO vertex buffer object, and then one is the ID for it, and then you call bind buffer to bind this type onto this object. I think it takes the address, takes a pointer to the object. Okay, so you pass an address to it, not actually VBO. It should be a pointer to VBO. It should be just like written like this, but yeah, anyways. From that point on, any buffer calls we make will be used to configure the currently bound buffer, which is VBO. Then we can make a call to the GL buffer data function that copies the previously defined vertex data into the buffer's memory. And then you have something called as static draw, size of vertices. Why do you need the size? is a function specifically targeted to copy user defined. Is a function that is specifically targeted to copy user defined data into the currently bound buffer. Its first argument is the type of the buffer we want to copy data into. The vertex buffer object currently bound to the GL array buffer target. The second argument specifies the size of the data in bytes we want to pass to the buffer. A simple size of suffices. Okay. The third parameter is the actual data we want to send, which is vertices. Okay. So I think what I'm saying here is send vertices to my GL array buffer and draw it statically. Okay. The fourth parameter specifies how we want the graphics card to manage the given data. This can take up to 3 forms: stream draw, static draw, and dynamic draw. Set only once and used by the GPU at most a few times. The data is set only once and used many times, and the data is changed a lot of times. I think this is something maybe for an actual game engine. The position data of the triangle does not change. Its use is used a lot. The position data of the triangle does not change, is used a lot, and says the same for every render call. So its usage type should be GL static draw. Okay. I mean makes sense. I should write it down. This seems important again. What? How did that get copied? I'm not. Streaming is such a difficult job. Brother, why are you getting copied? I don't want to copy you, just want to copy from here. Okay. Alright. The fourth parameter specifies how we want the graphic cards to manage the given data. Alright, I think I can indent it. This works, I guess. Maybe I can do this. Okay, since the position. Okay. This I think is also important. See, I don't know why, but I don't maybe somebody can tell me if it is an ADHD symptom where I tend to think as if like everything is important, and if my mind doesn't get an illusion of storing it somewhere, I tend to forget. How long the stream has already been? I'm not sure. Let me check. Around 44 minutes. Alright, that's fine. I mean, it's not that big of a deal, I guess. I'm also using Codex because it helped me a lot setting up Neovim with a good LSP. Okay. Okay. Vertex shader. The vertex. Alright. Okay. Nice. I finally reached this topic. Okay. Don't mind my English. It's not my first language. But finally, vertex shader. The vertex shader is one of the shaders that are programmable by people like us, the common people like us, common folk. Modern OpenGL requires that we at least set up a vertex and a fragment shader. Okay, vertex. If you want to do something if you want to do some rendering, so we will briefly introduce shaders and configure two simple shaders for drawing our first triangle. In the next chapter we'll discuss the shaders in more detail. Okay. Shadow vertex is this line itself is, I think, what should be taking a note of. The first thing we need to do is to write the vertex shader in the GLSL language and compile the shaders so we can use it in our application. Below you'll find the source code of a very basic GLSL shader. Okay, so I'm not sure if Neovim can identify this syntax, but the point is GLSL. Is it going? Oh wow! See, there is an OpenGL icon. Isn't it great? I am so impressed. For a millennial like me, I like to program in bigger fonts. Alright, so version 330 core is what I will be. Layout, location, what does it even mean? Location 0 in Vic 3, a POS, and then void main, and then you have a function. I mean, it's C by the looks of it. GL position vec 4, and then I guess a pos dot y, and then a pos dot z, and then this one is 1.0. I think these are just dimensions. In Vic 3, what does it really mean? In Vic 3, I mean, I do not know what to say. As you can see, GLSL looks similar to C. Each shader begins with a declaration of its own since OpenGL 3.3, and the higher the version number of GLSL match. Wait, dyslexia is ruining it. As you can see, this GLSL looks similar to C. Each shader begins with a declaration of its version since OpenGL 3.3, and higher the version numbers of GLSL match the version of OpenGL. 420, nice, corresponds to 4.2, for example. They also explicitly mention we're using the core profile functionality. Okay, I guess here. Okay, on a comment, very nice. I mean, I know it's not a comment, but I don't know. This looks very. I don't want to complain. I just want to learn. Next we declare all the input vertex attributes in the vertex shader with the in keyword. Next we declare all the input vertex attributes in the vertex shader with the in keyword. Right now we only have one. We only care about the position data, so we need a single vertex attribute. Oh, so this is, I think, where our I mean, where the x, y, and z coordinate will go into. Since each vertex has a 3D coordinate, we create a vec3 input variable, and with the name apos. It's such a nice name though, apos. Who decides that? We also specifically set the location of the input variable via layout. Location of the input. We also specifically set the location of the input variable. Location where? And you will see later that why we are doing this. Why we are going to need that location. Alright, fine. I mean, what can I say? Vector. In graphics programming, we use the mathematical concept of a vector quite often, since it neatly represents positions, directions in any space, and has useful mathematical properties. A vector in GLSL has a maximum size of 4, and each of its values can be retrieved via a vec xyz and w, uh, respectively, where each of them represents the coordinates in space. Note that the vec w component is not used as a position in space. We're dealing with 3D, not 2D. Okay, makes sense. So see, usually the fourth dimension would specify something like time if you are speaking in terms of physics, but yeah, but is used for something called perspective division. I mean, I don't know what perspective division is. Maybe what I'm talking about is exactly the same thing. We'll discuss vectors in much greater depth in a later chapter. Alright. To set the output of the vector shader, we have to assign the position. To set the output of the vector shader, we have to assign the position data to the predefined GL position variable, which is a vec4 behind the scenes. To set the output of the vertex shader, we have to assign the position data. Wait. So why does React come to my mind? I'm trying to see if it's a reusable component. Alright, again, to set the output of the vector, to set the output of the vertex shader, we have to assign the position data to the predefined GL position variable, which is a vec4 behind the scenes. Okay, this GL position, at the end of the main function, whatever we set GL position to will be used as output of the vertex shader. Okay, since our input is a vector of size 3 and we have to cast this to a vector of size 4, we can do this by inserting the vec3 values inside the constructor of vec4 and set its w component to be 1.0. If you'll explain this. Okay, this makes sense. Can I not write comments here if this is just like C code? So GL position is the output. See, syntax looks very weird, but I see the appeal. No. Thank you. My beautiful wife handed me a bottle of water. So if anybody who's listening, I'm married. I think I have to see what can I do on this channel to reach to a broader audience. Maybe I have to start. Okay, I wanted to make a joke. I'll make that later. Okay, so this is a float value and GL position is the output of this shader code, this vertex shader. Okay, the current vertex shader is probably the most simple vertex shader we can imagine because we did no processing whatsoever on the input data and simply forwarded it to the shader's output. In real applications, the input data is usually not already in normalized device coordinates. Wait. The current vertex shader is probably the most simple vertex shader. Okay, I get that part because we did no processing whatsoever on the input data and simply forwarded it to the shader's output. Oh, can you do processing here? GLSL, do we have any syntax for it? I mean, of course we have. It looks like C. I get this part. It's just saying that ensure that whatever data you are getting is normalized, and usually in real world scenarios you don't get normalized data. Oh, I see why Prime doesn't select the last character because it will select everything above it. So you can do this. Anyways, the current vertex shader is probably the most. Compiling a shader. Now, when I read this for the first time, I skipped the part where it says a const C string at the top of the code file for now. For now, okay. So maybe we will add it separately as like separate source files later on. Okay, so there is one thing where it says compiling a shader. So I have heard, being a gamer myself, what does compiling a shader mean? You take the source code for the vertex shader and store it in a const C string at the top. Okay, fine. I mean, that's okay. Should I add it directly in the source code? I mean, I guess so. I should. This is what I did earlier. I stored it as a raw string, but I mean, I stored it as a string, but what it's telling me now that it should be just a C style string, which I don't know the exact reason why. Maybe it has to do with these APIs being super old, I guess. But yeah, this is how it is asking us right now to deal with. This is really convenient. That is, you can create a raw string in C++ now. I searched for it and it told me this is how you should do it. Now in order for OpenGL to use this shader, it has to dynamically compile it. It has to dynamically compile it at runtime from its source code. The first thing we need to do is to create a shader object, again referenced by an ID. So we store the vertex shader as an unsigned int and create the shader with the GL create shader. This is so interesting. So although these tiny pieces of code I mean, it's more, it, it works like scripts. I mean, maybe some OpenGL veteran might explain this better. I mean, this dude definitely is one OpenGL veteran, because this tutorial is insane. It is terrific. So what they mean to say is, so what you're saying, I tried to reference a meme, but yeah, I get this part. So all these games, which whenever they say they are trying to compile shaders, so they're just running the code in my graphics card. I mean, of course they are, but I never knew. I never knew it is that complex, it is that hardcore. GLSL, GLSL it is, yes. Is it GLSL? No, this is C++. Hmm. GL Vortex Shader. So, alright. What was array buff? What was it? Yes, GL array buffer. So GL array buffer is different. GL vertex shader is different. I mean, see, they were constraints by the design which they had at that time. I wish this API was made a little better. But see, that's the catch here. I want to learn the old way of doing things. If you don't know how to write it in the from the first principles, you will never understood the details when they will actually come and bite you. We provide the type of the shader we want to create as an argument to GL create shader. Since we are creating a vertex shader, we pass in GL vertex shader. Next, we attach the shader source code to the shader object and compile the shader. Okay. Alright. I mean, again, all of this is super important in my opinion. This is how I will usually learn, like whenever I'm trying to learn a framework, or let's say any technology from the internet. I often tend to just copy paste, because I might need it later. The GL shader source function takes the shader object to compile. The GL shader source function takes the shader object to compile to its first argument. Okay. Takes the shader object to compile as its first argument. The second argument specifies how many strings you're passing. Oh, wait, what? What? GL shader source and then vertex shader 1 shader source null. Then it says function takes the shader object to compile. Okay, I get this part. Vertex shader, it's the one which was created before. The second argument specifies how many strings we're passing as source code. The second argument specifies how many strings we are passing as source code. Okay, which is only one. The third parameter is the actual source code of the vertex shader that we can leave, and we can leave the fourth parameter. Alright, why does it have to be null? I don't get it, and the author doesn't want to tell me. That is fine, maybe, but this is good. This is actually good. change a coding font. Nope. Should I use iOSFK? Do I have iOSFK? Do I have? Yep, I have iOSFK installed. This is the best font. Okay, I don't have the slab one, but this iOSFK, I mean, it's great. You, you you get like so much screen real estate when you use iOSFK. It's actually insane. Somebody may say that this looks a lot like how sorting does it, but yeah, I mean, what he uses is Gruber Darker on its Emacs, but again, the idea is you can do this in the web perfectly fine. You probably want to check if the compilation was successful after a call to GL compiler shader, and if not, what errors were found, so you can fix those. Checking the compile time errors is accomplished as follows. See, I have so many opinions right now, which I am refraining because these people these people must be insane to create these abstractions, right? But then, why? I mean, I see it that you get to use C++ as your you're essentially using C++ to compile as a build system. Using C++ as a build system is insane, because what can be more lower level except machine learning than C++? I mean, usually your build systems are written in languages which are generally scripting languages. So I mean, this is good. I'm not going to complain. First, we define an integer to indicate success in a storage container for the error message, if any, and then check if the compilation was successful. Shader rev. What is shader rev? What does uh, what does Ivy mean here? And why is this going to shader rev? If the compilation failed, we should retrieve the error message and print the error message and then return, I guess. That is to not do anything more than that. Yep. Nice. Actual nice code. I know I will trigger a lot of people because I use this right angle braced, right curly brace. Oh wow, it immediately tells me that for some code points wish to install additional fonts. Yeah, I get it. Okay, see, maybe I could also use maybe you can just decide not to use any local font, custom font, that is. If I comment out this code, will it give me any errors? I don't think so. See, why did Fira code have it? How many fonts do I really have? I did install many nerd fonts. I have Open Dyslexic as well. Deja vu. Okay. Nah. Ayosafka is okay. Let's just keep Fira. Hmm. Wow. Also, see, I'm using Z Oxide. It's the best, the most usable tool anybody could have ever made. So yeah, let's just continue. So much stuff, and it's already been an hour, I believe, and still the triangle is not yet on my screen. If no errors were detected while compiling, the vertex shader is not compiled. Fragment shader. Okay, so I think whenever a game says they're compiling shaders, what they mean is that they are compiling the vertex shader and maybe all the other shaders in the pipeline. And what is a shader? A shader is a small piece of code. That's how I would define it. Fragment shader. Fragment shader. Is there a second and the final shader we're going to create for rendering a triangle? The fragment shader is all about calculating the color output of your pixels. To keep things simple, the fragment shader will always output an orangish color. Okay. Okay, to keep things simple, the fragment shader will always output an orange-ish color. Orangish color. Alright. See, UI programming is great. I mean, if all you do is write CRUD operations, you're nothing, you're just a CRUD monkey. And since this is done so many times, AI is for sure going to take your job. You have to step up your game and actually do something other than doing database operations. Same thing can be said about React. If you just know how to make an API call and then show that result back, you're not gonna make it. And GMI. Keyboard. Keyboard. Keyboard in. Thank you. One sec. Alright. I was sitting in a very weird position, so I decided to change my keyboard. Separate myself away from the screen. See, this is the speed which Neovim gives you. 60 frames per second. Okay, so what they say is that the fragment shader is the second and the final shader we're going to create for rendering a triangle. The fragment shader is all about calculating the color output of your pixels. To keep things simple, the fragment shader will always be an orangish color. Will always output an orangish color. Alright, and how do you do that? This is, I believe, orange. Colors in computer graphics are represented as an array of 4 values: red, green, blue, and alpha. Commonly abbreviated as RGB. I mean, I get that. So the way you would create your GLSL, I guess, will be then what is the syntax? Version What was the first keyword here? 330 and then core. Next is out vec4 fragment color, I guess. Alright. What is up with these uppercase character names? I don't get that. Is there no common syntax of writing your variable names from the game community? I don't know, maybe void main, and then again it is your frag color. This is vec4. What is yellow? What is yellow RGB? I mean, the fact that I'm spending tokens just to figure out what's the value, what's the value of RGB, it's insane. Red and green. So what? You mix red and green to get yellow? I'm blind as hell. 0.0 F. Okay. I think there is some setting using which you can decrease the size of your Windows icons. I should go to left. Hidden. OBS. Maybe I can have OBS here. No, I don't want to hide OBS. What did it do? Lord have mercy. This looks very ugly. Not gonna lie. I wish this was more customizable. Can I change that? Nah. Anyways, we're almost, I guess, above an hour, and I have still not rendered a simple triangle. So version 330 core, out vec frag color. Okay, the fragment shader only requires one output variable, and that is a vector of size 4 that defines the final color output that we should calculate ourselves. We can declare output values with the out keyword that we here promptly named frag color. Fragment color, is it? So are we defining the color of a single fragment? Next, we simply assign a vec4 to the color output as an orange color with an alpha value of 1.0 being completely opaque. Okay, and we're not going to go with 1.0 because it will not like orange. That's why we're going to go with yellow. The process of compiling a fragment shader is similar to the vertex shader, although this time we use the GL fragment shader constant as the shader type. Makes sense? Alright. Okay. Both the shaders are now compiled, and the only thing left is to link both shader objects into a shader program we can use for rendering. Make sure to check for compile errors here as well. So see, there are multiple ways to do it, and I believe like there will like exist libraries which will see. I've written software a lot, and one thing you usually do while writing software is like assertion errors. That is, your environment should never have what you never intended it to have. Just like a safety check. That is, crashing is an expected behavior. So okay, moving on. Let's also try to time bound ourselves. Maybe 20 minutes. We'll have like just 20 more minutes to finish the reading part at least, because I really want to write some code. Okay, both the shaders are now compiled, and the only thing left to do is to link both the shaders. Shader program. Finally, I reached shader program. Alright, you pass in GL fragment shader, and then the same thing. This is the number of source files, and this null value is still not defined by the author, so we'll keep it as it is. I'm so happy that I decided to set up Neovim properly. I mean, I don't want to have that overhead of learning Visual Studio just because I want to learn writing C++ or maybe writing about graphics programming, because I already knew Neovim and I have this muscle memory which just does things for me. Why would I even try to learn Visual Studio? It's just a waste of time, waste of my time, bless the open source community. Okay, shader program. Okay, we did not write anything like that. Okay, a shader program object is the final linked version of multiple shaders combined. I can only imagine how difficult it would have been to make Cyberpunk without AI, without ChatGPT or Claude. I mean, see, Cyberpunk will always be um, the best game which I have ever played. Visually as well as story as well as gameplay, it's just excels. It is just top of the class. Okay, to use the recently compiled shaders, we have to link them to a shader program object and then activate the shader. Wait. To use the recently compiled shaders, we have to link them to a shader program object and then activate the shader program when the rendering objects. The activated shader programs shaders will be used when we issue render calls. So see, I see it. I'm trying to build intuition for OpenGL, and this makes sense. This makes a lot of sense. That you have a program whose and all it does is just render, and maybe in different loops or maybe on different events you will change these. For example, vertex shader or the fragment shader, you change the colors, maybe on a different loop. I can play around with that. I think I can. I mean, I'm getting like so many ideas right now. I want to see how much stuff I can do with what I already have. Because see, this is what makes you a good programmer, is your ability to do stuff with what you have, not what you would like to have. Hmm, pretty insane, pretty insane. When linking the shaders into a program, it links the outputs of each shaders. Wait. When linking the shaders into a program, it links the output of each shader to the inputs of the next shader. This is also where you'll get linking errors if your outputs and inputs do not match. Nice. I mean, it's just CMake. Is gaming just CMake? Is writing game is game dev just CMake? I'm glad like I learned CMake just before jumping to game programming, because I was like, I am having skill issues. I'm not able to write a good build system for Neovim because I was so hell bent on using Neovim on Windows. I feel so happy about it. I'm glad. I'm just glad I did that. So believe it or not, game dev is just CMake. Now creating a program object is easy. An unsigned shader program, and then you create a shader. And see, this is also great because earlier I think they had no way of creating objects like you can do with modern C++. When I say objects, I'm talking about object-oriented programming, because object-oriented programming makes a lot of sense when you have to build these abstractions. I mean, I would have never realized that a shader is an unsigned int. I thought shader is this complex piece of software, but it's just bytes stored in their memory. Isn't that great? It's absolutely beautiful. It's absolutely beautiful how it just boils down that these abstractions in the end are just bytes in your CPU running in your memory stored in your GPU running, I guess. Yep. Absolutely love the idea. So the GL create program functions create a program and then returns the ID. The GL create program functions create a program and returns the ID reference to the newly created program object. Now we need to attach the previously compiled shaders to the program object and then link them with GL program. Okay, so program and returns the ID reference to the newly created program object. Why do you need a program? What is a program? What's a program? Why do you need one? Why a program is like just what I want to know. See, program is, I mean, is it an executable? I wish like they were more specifics, but I guess doing anything more than that, I mean, it's already technical. But my good brother tried to use language which could be more, which could be the most efficient way to communicate this to somebody who might not know what shaders are. But this is actually very good. So you create a shader program like this, and then GL creator program creates a program that is a reference to, okay. So shader program does the job of linking shaders. That's it. I mean, I just read that. So first you attach the so what you essentially need to do is to attach your whatever shaders which you might have defined to the shader program, and you have to also ensure beforehand that this vertex shader should compile for your machine. Pretty insane. Very nice though. All of this information is publicly available, and like some dude will just decide to sell this for like 10,000 bucks. The code should be pretty self-explanatory. It is, my man. We attach the shaders to the program and link them via the GL link program. Just like the shader compilation, you can also check if linking a shader program failed and retrieve the corresponding log. However, instead of using the GL shader IV and GL get shader info log, we now use get program IV. What is IV? Why IV? I want to know. I really want to know why does it use the word IV. Let me ask GPT. Why is there an IV? What does it mean? Go. Return value. Wait. Query state from a program object. The return value type is glint. What? Write the result through a pointer, potentially as an array. What? What? Why? I mean, I guess you don't ask why. They call Rust the authoritarians. And okay, I take my words back. It is very readable. It just says integer vector, I guess. Integer int vector, I guess. That's how I can. I is like integer valued by a pointer. Get integer valued by a pointer. Oh, get float value via a vector. Get one float value. Who the hell decided that? Anyways, I'm like again nitpicking. I shouldn't do that. The result is a program object that we can activate by calling GLUse program with the newly created program object as its argument. Alright. Okay, I think I copied the entire thing. GLUse program. Every shader and rendering call after GLUse program will now use this program object and thus the shaders. Every shader and rend. Wait. Oh, nice. Every shader and rendering call after GLUse program will now use this program object and thus the shaders. Wow. So I can create 1,000 shaders, is that what they mean to say? I don't know. Oh yeah, don't forget to delete the shader objects. Since you've linked them into the program object, you no longer need them anymore. I mean, I could have never guessed. Thanks for letting me know that C++ is not garbage collector. You have to either use smart pointers everywhere or just leak it. Who cares? It's not like you're building a spaceship. I mean, who cares? Yeah, and no note. Don't forget to delete the shader objects. I get that part. I really get that part. And the way you would do it is think GL delete. I think somewhere you're gonna have that vertex shader and the fragment shader. I wish I could program like this forever. I wish like web development was this exciting. Okay, so right now we send the input vertex data to the GPU and instructed the GPU how it should access the vertex data within a vertex and a fragment shader. We're almost there, but not quite yet. Oh my god. I mean, I think I have to spend another hour just to figure out. Oh no. Oh no. Okay. Okay. Finally, a triangle will be there. Okay. I see you. I see that triangle. Gonna get that soon. But still, I think there is a lot we need to understand before trying to make a triangle. I mean, it makes sense. I want to know the details about the specification so that I can actually write programs myself. Yeah. What else can I do? Right now we send the input vertex data to the GPU and then instructed the GPU how it should process the vertex data within a vertex and a fragment shader. We're almost there, but not quite yet. OpenGL does not yet know how it should interpret the vertex data in memory and how it should connect. Wait. Okay, I mean I get that because we just declared stuff. We didn't tell it how it should use those actual coordinates. This is actually good because see, I've done some graphics programming with P5.js, and when I used P5, you don't have to worry about the shaders part. It just gives you a nice interface to draw stuff, and that was pretty nice. I mean, those abstractions were really good. But this is way more low level than that. What you're gonna get at the end is going to be way more robust. I mean, robust is the wrong term, I guess, but way more lesser in size and higher in performance. I guess these two things are the only things I worry about. Alright, let's go. So right now we sent the input vertex data to the GPU and instructed the GPU on how it should process the vertex data within a vertex and a fragment shader. We're almost there, but not quite yet. OpenGL does not yet know how it should interpret the vertex data in memory and how it should connect the vertex data to the vertex shaders attribute. Okay, OpenGL does not yet know how it should interpret the vertex data in the memory and how it should connect the vertex data to the vertex shader attributes. Will be nice and tell OpenGL how to do that. Oh my god, this is such a sarcastic way of saying it, but I mean, yes. I mean, he's dunking on him, but he's dunking on OpenGL, but makes sense because still nowhere on these like 257 lines of like notes which I took that I wrote down any triangle anywhere. See, because I'm yet to write the source code, still I'm taking notes. Copy that. I'm not going to speedrun games again. The complexities developers go through and like people just end up taking a dunk on them. They don't realize how complex these things are. How see art is difficult. You could have just used Unreal Engine, right? If you just want to ship games. I mean that's what CDPR is doing right now when they decided to not use Red Engine for their new I guess Witcher, but I mean who am I to decide, right? See, one thing really good about what I did here, this timer actually tells me how much behind my stream is. So around 30 seconds. Oh no. Anyways, So linking vertex attributes. Alright, this is another beast. I mean, by the way they're saying that linking vertex attributes. Let me take a deep breath. I have a really good idea. You can try Golang to create. I think Prime did that already, creating shaders for the terminal where he rendered Doom. Insane. Maybe I can create a small game where two characters are fighting, but it's the LLMs who are actually doing the fighting. Maybe Claude versus GPT on a chess. This would be great. This would be actually very great. I mean, I mean, just such a great idea. Such a great idea. Let me write it down. I will get so many views. Claude versus ChatGPT. Chat GPT. Chatbot GPT. Chess. There are so many chess nerds out there. They're gonna love that. They're gonna absolutely love that. It will be an interesting project. I mean, just a harmless project. Something I'd like to do on the side. Alright. Linking vertex attributes. The vertex shader allows us to specify any input we want in the form of vertex attributes. And while this allows for great flexibility, it does not mean we have to manually specify what part of our input data goes to what part of our input data goes to which vertex attribute in the vertex shader. I don't get it. The vertex shader allows us to specify any input we want in the form of vertex attributes. Okay. Okay, I mean, I get it. You have defined one piece of code and it takes some input and it shoots out some output. While this allows for great flexibility, it doesn't mean we have to manually specify what part of our input goes to which vertex attribute. Okay. The vertex shader. Okay. Oh yeah. I mean, makes sense because you only have this one instance. I mean, if you are creating. Okay. In my mind, what I'm thinking, what they mean to really tell us is, if you have one instance of this piece of code running somewhere on your CPU, what he means to say is that currently there is no way of passing like which vertices, which vector will be rendered. I mean, what he means to say, I guess the order is not yet defined, is that so? The vertex shader allows us to specify any input we want in from the vertex attributes, and while this allows for great flexibility, it does not mean we have to manually specify what part of our input data goes to which vertex attribute in the vertex shader. This means we have to specify how OpenGL should interpret the vertex data before rendering. Our vertex buffer data is formatted as follows. Now I miss org mode or emacs because I know I could have taken a screenshot and then could have attached this on the source code. But what they mean to say is that if you have, okay, so vertex, see, first of all, it's an array. because like your index starts with 0, then 4, 8, 12. So it's a 4 length byte. You have one vertex. Oh, okay. It's like showing the internal representation in the memory. So it's an array. Ah, it's just the float array. The float array being represented. And then you have position and then stride. What you call stride, and there is like offset 0. What you call stride is the length of one vector in the memory. You have said that the position data is stored as 32 bits 4 byte. Each position, wait, 4 byte floating point values. Each position data is composed of 3 of those values. Where does the fourth one go? I think it's for Indianness. There is no space or other values between each of these values. These values are tightly packed in the array. The first value in the data is at the beginning of the buffer. The first value in the data is at the beginning of the buffer. With this knowledge, you can tell OpenGL how it should interpret the vertex data. It's picking up noise. Wait, so the position data is stored as 32 bits 4 byte floating point values, and each position is composed of 3 of those values. There is no space between each of these 3 values are tightly packed. Okay, with this knowledge you can tell OpenGL how it should interpret the vertex data. GL vertex attrib pointer 0, 3, GL float, GL false, and 3 times size of float. Isn't it just the length of the array? And then a void pointer. Lord have mercy. Enable vertex attribute array 0. I mean, insane. That doesn't. The function in vertex attribute pointer has a few. Okay, wait. Let me do this. Linking vertex attributes. Now I wrote that. Where did I reach? Okay, let's start another timer for 60 minutes, I guess. 1 hour. Okay. What it says is that the vertex shader allows us to specify any input we want in the form of vertex attribute. Let me copy that. Okay, vertex data buffer is formatted as below. The position is stored. I'm just gonna write this because I cannot store it. Yeah, I mean all the Emacs evangelists will be there in the comment section saying, oh, you cannot store images in with Neovim, you cannot render them. Okay, guess what, someday we will. COVID Goyal, that Giga Chad nuclear physicist, ex-nuclear physicist, the maker of Kitty Turner, is going to do that someday. And then these Emacs editor users are not going to have even a single argument against Neovim. because org mode is the only thing that is keeping Emacs, that is giving Emacs a chance to even fight against Neovim. Neovim does everything Emacs can except variable size fonts. Someday it will happen. MC, I'll tell you, Emacs was dog water. It was very bad on Windows. I tried that. Western and Neovim just works well. It just works great. It works really, really good. Okay, so I stored this part at least. With this knowledge, you can tell OpenGL how it should interpret the vertex data per vertex attribute. Okay. And should you be doing this outside loops or inside loops? I mean, if I'm declaring this, then this is GL vertex attrib, and then void pointer. Nice. The function GL vertex attribute pointer has a few parameters, so let's carefully walk through them. Oh my god. The first parameter, I mean, see, this is where Rust wins. If it were not for this learn OpenGL, I would have, nobody in this world could ever explain this paragraph to me better. I mean, I shouldn't deviate. Let's just finish this. This first parameter specifies which vertex attribute we want to configure. Remember that we specified the location of the position vertex attribute in the vertex shader with the location layout 0. This sets the, wait, okay, this is the location of the vertex attribute to 0. Since you want to, this sets the location of the vertex attribute to 0, and since we want to pass data to this vertex attribute, we pass in 0. But where is 1? Then the next argument specifies the size of the vertex attribute. The vertex attribute is a vec3, so it is composed of 3 values. The third argument specifies the type of the data, which is GL float. In a vec pointer in GLSL consists of floating point values. The next argument specifies if we want the data to be normalized. If we were inputting integer data types int byte and we set this to GL true, the integer data is normalized to 0 and 1 when converted to float. Okay, they have given the definition of normalization here. This is not relevant to us because we'll leave this at GL floats. We're using floats, that's why. Okay, so the fifth argument is known as the stride. This tells us the space between consecutive vertex attributes. Since the next set of position data is located exactly 3 times the size of a float. Oh wait, 3 times the size of a float away, we specify that value as the stride. Okay, this is just Note that since we know that the array is tightly packed, there is no space between the next vertex attribute, we could have also specified the stride as 0. To let the OpenGL determine the stride, this only works when values are tightly packed. Whenever we have more vertex attributes, we have to carefully define the spacing between each vertex attribute. But we'll get to see more examples of that later on. The last parameter is of type void pointer and thus requires that weird cast. This is the offset of where the position data begins in the buffer. Since the position data is at the start of the data, this is the offset where the position data begins in the buffer. Since the position data is the start of the data, start of the data array, this value is just 0. We will explore this parameter in more details later on. Did I write it down? Oh, this piece of information is also insane. I mean, I don't know, maybe I'm just taking a lot of time, but this is just how I do it. Sometimes me not being very good in English hurts me a lot, where I will go through stuff and I'll end up ending not understanding things logically, and then there is this inferiority which comes in my head, which tells me that why are other people getting it but you not? You speak the same English, you understand the same logical rules, but why do just some people get it and you don't? I don't know. I just that's why I decided to be an engineer, because engineers make stuff work. They are into. I mean, being a physicist or an engineer is like what I'm trying to make a contrast about. Okay. A lot of stuff. What else? Each vertex attribute takes its data from memory managed by a VBO. Alright. And which VBO it takes its data from, you can have multiple VBOs, is determined by the VBO currently bound to GL array buffer. When calling GL vertex attribute pointer, since the previously defined VBO is still bound before calling GL vertex attribute pointer, vertex attribute 0 is now associated with its vertex data. What? Is it okay if I do not understand it, like around 8 to 5 to 8% of it? See, it says like each vertex attribute takes its data from memory managed by VBO. Yeah, fine, you can just say that since VBOs are just bytes in the memory, and which VBO it takes its data from is determined by the VBO currently bound to the GL array buffer. Okay, so whatever piece of memory was bound to GL array buffer, vertex shader, each vertex attribute is like when they say, okay, so when they say vertex attribute, what they mean is the vertex shader's input vertex attribute takes its data from the memory managed by a VBO, and which VBO it takes its data from, you can have multiple VBOs, is determined by the VBO currently bound to the GL array buffer. And when calling GL vertex attribute pointer, when calling GL attributes pointer, since the previously defined VBO is still bound before calling vertex attribute 0, is now associated with its vertex data. What? Since the previously defined VBO is still bound before calling 0 data attribute 0 is now associated with its vertex data. Did he forget a comma somewhere? This statement doesn't make sense. I mean, I don't know, I may be dumb, but I have no idea. Now that we specified how OpenGL should interpret the vertex data, we should also enable the vertex attribute. Will GL enable vertex attribute array? Okay, first is copy our vertices array in a buffer for OpenGL to use. You define the VBO and then bind it, and then buffer data. You tell it about the stride, and then the vertex attribute pointers, which is GL attribute pointer 03 GL float GL. Okay. Second function call is like telling it to draw it statically. I mean, what it says, like, it's not going to change much. Instead the vertex attribute properties, GL enable vertex attribute 0. GL enable at is 0 the location of that vertex attribute there is 0. The user shader program when you want to render an object. GL use program, shader program, some other OpenGL function that draws our triangle. Okay, that's a lot of things happening at once. Alright, what should I do next? GL bind buffer. I can combine all of these in a single. Okay. CPP. I want to take time learning this because I don't want to miss anything. Missing stuff has always been. I don't want to rush it, is what I mean to say. Yes, I want to ship games. Yes, I want to create the next Call of Duty. Maybe create something artistic, like representing myself in a game that other people can enjoy. Storytelling is like what I want to do, and I want games to be the medium for that. Games and maybe in general like learning graphics programming and upskilling my day job. Upskilling at my day job. Okay, so anyways, I shouldn't be. Okay, we have to repeat this process every time we want to draw an object. It may not look like that much, but imagine if we have over 5 vertex attributes and perhaps hundreds of different objects, which is not uncommon. 5 vertex attributes. Okay, so you can draw like multiple. See, if your vertex shader has 5 input attributes, so see, I think it makes sense to draw, to have like different source files for these GLSL programs because they're shaders. Okay, building the appropriate buffer also. Okay. Now imagine if we have over 5 vertex attributes and perhaps hundreds of different objects, which is not uncommon. Binding the appropriate buffer objects and configuring all vertex attributes. Binding the appropriate buffer objects and then configuring all vertex attributes for each of these objects quickly becomes a cumbersome process. I mean, it is. For one, you have to write like 5 lines of code. What if there was some way we could store all these state configurations into an object and simply bind this object to restore its state? What? Why did you have to enter a statement with bind this object to restore its state? Where is it restoring its state? Why do you have to restore state? I don't know. Vertex array object. Vertex array object also known as VAO. So we had like VBO, vertex buffer object previously. We had VD, what was that? Normalized data coordinates, NDC. We had. I mean, they're loving the acronyms, so like what I mean to say, not gonna lie. These graphics programmers, they just love shit. See, that's why C++ programmers are going to hate JavaScript programmers, because JavaScript just works. I can write a triangle with like 10 to 15 lines of code. So browsers are this amazing piece of technology. I mean, I'm glad I'm a web developer. Vertex array object. A vertex array object, also known as wow, can be bound just like a vertex buffer object, and any subsequent vertex attribute calls from that point on, just like a vertex, and any subsequent can be bound just like okay, bound to what? Over here, and any subsequent vertex attribute calls from that point on will be stored inside the wow. This has the advantage that when configuring vertex attribute pointers, you will only have to make those calls once, and whenever we want to draw the object we can just bind the corresponding wow. This makes switching between different vertex data and attribute configuration as easy as binding a different wow. All the state we just set is stored inside the wow. Okay, I mean a lot of text with a little bit of knowledge to share. Maybe I am getting tired. Let's see. I really wanted to just to render the triangle. Where are we? How much more do I have to go through this? Lord have mercy. Almost there. Let's do this. We got 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 this. Let's not give up. Okay. So we have to repeat this process every time we want to draw an object. It may not look like that much, but imagine we have to draw. Okay, I read that. Okay, just give me a sec. A vertex array object, also known as wow, can be bound just like a vertex buffer object, and any subsequent vertex attribute calls from that point on will be stored inside the wow. This has the advantage that when configuring vertex attribute pointers, you only have to make calls to those ones, and whenever we want to draw the object, we can just bind the corresponding wow. This makes switching between different vertex data and attribute configurations as easy as binding a different wow. All the state we just set is stored inside the wow. Wow. Core OpenGL requires that we use a wow, so it knows what to do with our vertex input. If you fail to bind a wow, OpenGL will most likely refuse to draw anything. This is just good wordplay. If he failed to bind a wow. Harry Potter reference? Nice. In a web dev where I'm glad to learn to pitch. Just do my first. Okay, I don't want to show my credentials. Else I would have logged in. Oh, this was insane. This is very good. Login with or sign up and discuss. I'll do that later. But it's just nice. Okay. I got this. I almost got this. It's just so much information I have to can bound just like a bird subsequent okay, advantage. Okay, I can let me write that down. This is like important stuff. Did I write? What did vertex array object? Okay. Core OpenGL requires that we use a wow, so it knows what to do with vertex inputs. If you fail to bind a wow, OpenGL will most likely refuse to draw anything. This actually makes sense. I mean, OpenGL. Okay, so there are two things which are required. First is that you need to define two shaders at least, I guess. One the fragment shader, the vertex shader, and then you must create a vertex array object, so that this is like where OpenGL will actually know what to do with the declared data. I mean, it's also great you're declaring stuff instead of imperative, because see, somewhere in your program you have to declare something that the corresponding abstracted piece of code on that declaration should execute. Somewhere it has to happen, right? You can't just add imperative logic everywhere, because it goes in depths. I mean, I'm not telling exactly what bytes will be stored at what place. I mean, how deep does it go? Is CPU instructions the last step, or does it go beyond that? It goes to like atoms and then nucleus and then like electrons and then these particles. Where does it stop? It's amazing. Where do you stop declaring is like what I mean to say. Such a great thing to think about. Like we programmers, we use these abstractions, these APIs. I mean, some other programmer has made your life easier by creating something which you can use, although it comes as a cost, but you should be on their mercy. I mean, is universe an API? Physics is an API. Physics is a specification. It 100% it is a specification. Because how else would you define it? If not a specification, if not rules which guide the behavior of the objects, of these physical objects surrounding you. I'm going like hardcore on this shit. A vertex array object contains the following: calls, calls to the GL enable vertex attribute array, or GL disable vertex attribute, vertex attribute, vertex attribute. Why was there an attribute word here? I think it comes from your shader definition. Vertex array object stores the following, or it calls to the vertex attribute configurations via the GL vertex attribute pointer, vertex buffer objects associated with vertex attributes, vertex buffer objects associated with vertex attributes by calls to GL vertex attribute pointer. Oh, I mean, again, it's a lot of stuff to remember. I mean, it is fine. Maybe I won't be dealing with this, but I'm not sure how much of it will be used, so I have to learn about it every. It's like what I meant to say, that I have to learn about it anyways. My wife is playing the game. She loves that. Okay. Vertex attribute configurations via GL vertex attribute pointer. Alright, alright. Vertex buffer objects associated with vertex buffer attributes were called to this. I enjoy this. I'm really enjoying the aspect of learning graphics programming. As difficult it is, it's great. So far it's great. So far it's really good. Wow. Wow. Vertex buffer objects associated with vertex attributes by call to GL vertex attribute pointer. Okay. The process to generate a wow looks similar to that of a VBO. See, from the looks of it, if you have one vertex array object and you have like multiple attribute pointers, one attribute pointer points to what? A vertex buffer object? Okay, one vertex attribute object points to one. See, vertex array object is just an array. It is storing pointers to vertex buffer objects in the memory, and those vertex buffer objects themselves are separated via stripe. Huh, makes a lot of sense. and then wow2 points to, where does it go, pos 0, and then attribute pointer 1 points to call 0. Why is there a call 0? Where did call 0 come from? What? Okay, these are just strides. I guess these are just strides, right? So what it means to say, I guess, that stride can be epsilon positive. The process to generate a wow looks similar to that of a VBO. Okay. I mean, I guess it is a similar process. Unsigned and wow. GLG and vertex arrays. Wow. Wait, what? Am I not creating another integer in the memory? Then how it is a wow? And see, what is great about it? Can you guess the memory footprint of my source code at least? It's just bytes. Simple bytes. I'm not pulling in like 1,000 npm packages just to render an array. This is great. This is great. As low level it goes, I think this is the most low level. I'm not sure if there is any further abstraction that exists, because OpenGL is a specification and specifications usually don't get lower. I mean, if you these are just it's just a standard. You can't change the standard, huh? If you want things to work. To use a wow, all you have to do is to bind the wow, binding vows using GL bind vertex array. Using GL bind vertex array function. Alright. From that point on, we should bind or configure the corresponding VBOs and attribute pointers, and then unbind the wow for later use. As soon as we want to draw an object, we simply bind the wow with the preferred settings before drawing the object, and that is it. In the code is it. Lord have mercy. So what is saying that you can reuse a wow? To use a wow, you have to introduce the bind the wow using. Okay, I get that part. To use a wow, that you have to bind a wow. I get this part. From that point on, we should configure the corresponding VBOs and attribute pointers, and then unbind the wow for later use. As soon as we want to draw the object, we can simply bind the wow with the preferred settings before drawing the object. That is it. Okay, I think I should take a break after this, because this is just a lot of information to consume. But I am going to finish it. I'm not gonna take a break of like more than 30 minutes or something. But yeah. Okay, so C++ code corresponding to that is gonna look like initialization code done once unless your object frequently changes. Bind the vertex array object. Alright, copy your vertices array in a buffer for OpenGL to use. Okay, so see this step is done before you are defining a VBO. And then set your vertices attributes pointers, and then bind the vertex array. Some OpenGL function that draws a trend line. It's a lot of code. Just to. I mean, see, people have made memes about how difficult Vulkan is, but OpenGL is also difficult. Maybe it's because I'm learning it for the first time, so I don't have anything to compare it with. But I can only imagine how when it is difficult, but it's a community accepted term. Okay, and that's it. Everything we did in the last few million pages led up to this moment. a wow that stores our vertex attribute configuration and which VBO to use. Usually when you have multiple objects you want to draw, you first generate, configure all the wows, and this the required VBO and attribute pointers to store those for later use. The moment we want to draw one of our objects, we take the corresponding wow and bind it, and then draw the object and then unbind the wow again. This looks nice, actually very nice. The triangle we've been waiting for. Okay, let's effing go. Let's go. Triangle we've been waiting for. To draw our objects of choice, OpenGL provides us with GLDrawArrays function that draws primitives using the currently active shader. The previously defined vertex attribute configuration and with the VBO's vertex data indirectly bound via the wow. Makes sense. So if you just started here, maybe see you could have also started depth first, right? There was no need to define everything first and then, because see, somebody trying to learn is not gonna understand it anyways, so why not just tell them what the abstraction is and then move down the abstracted stuff that way. I mean, at least like this is how I would learn. I mean, I see it. I mean, it is. Maybe I'm not saying what my mind wants to say. I don't know. I don't know. GL use program, shader program, GL bind vertex array, VAO, GL draws arrays. Alright. So you can. I'm glad I'm doing this instead of writing Java. Java just is so. I mean, I don't know. Like for some people, it might be their bread and butter. For me, it's JavaScript. Building UIs, building anything visual is just so much more fun than just staring at a terminal. Okay, the GLDrawArray function takes as its first argument the OpenGL primitive type. Okay, we want to draw. Since I said that at the start we want to draw a triangle, I don't like lying to you. We pass GL triangles. So GLDrawArrays. Okay, the last argument, the second argument specifies the starting index of the vertex array we'd like to draw. We just leave signifies the starting index of the vertex array we'd like to draw. We just leave it at 0. The last argument specifies how many vertices we want to draw, which is 3. We only render one triangle from our data, which is exactly. Wait. My mind just deviated. The second argument specifies the starting index of the vertex array. The second argument specifies the starting index of the vertex array. Starting index of the vertex array we would like to draw. Just leave it as, the last argument specifies how many vertices we want to draw, which is 3. Okay, but we only render one triangle from our data, which is exactly 3 vertices around. But see, where did you color it? I'm not specifying the fill value, is it? You get what I mean to say? The fill. This would be a nightmare for somebody who is always writing backend code. Now try to compile the code and work your way backwards if any errors popped up. As soon as your application compiles, you should see the following result. The source code of the complete program can be found here. If your output does not look the same, you probably did something wrong along the way, so check for the complete source code and see if you missed anything. Okay, so this is like what we're supposed to do. I mean, I won't stop unless a triangle is rendered, but I do need a short break. So see, this is what we're gonna do. I can maybe write, where did I write notes? Break.md. break of 20 minutes. And I can say, like, I did not do it before. Can I say 20? What's gonna happen? It replaces the object. I will be right back. Fuck. 20. It'll take a moment. Okay, so we are back with this right on time. I feel a little better. So what I need to do before moving here, I think I should first write down the entire code for it, right? Okay, let's make the triangle work. Here we go. Okay, so this is the fragment shader code and this is the vertex shader code. These are just the callbacks which I think I defined previously. You have auto main, screen width and screen height. Let's change it to, what did I press? Caps lock is clap was on. Let's change it to 800. Nice. Background 237. Let try and last. Null pointer. Okay. Hello triangle. Alright, GLFW terminate. Okay, so do I call GLFW terminate again and again? If you get a null pointer, I mean if you don't get a window, then it's gonna fail, I guess. Okay. GLFW make content buffer. Failed to initialize glad. Ended success. I should call it glad. Okay, and then see, this is a condition. I could have written a not here, but then converting it to a strict boolean just makes more sense. Alright, so you terminate and then here you do this. So alright, so I think just after you declare, I don't need this piece of code. I'm not on Windows. Sorry, I'm not on Apple. Unsigned vertex shader. Yep. There you go. You gotta type that out. I think you should type that out. It is unsigned end. Declaring vertex shader. Unsigned ends VBO. Not VBO. Am I getting it wrong or what? What is it that am I getting wrong about? Okay, here you declare your VBO. First you are just declaring the code for your shaders. Okay, unsigned end VBO. I'm almost done with I really want to create variables like this. I don't want to use a camel case because I want a way to be able to tell that this is the code which I wrote. That's why I'm gonna use snake case. Who cares? Who cares? Vertex shader. So you have like vertex shader. GL create shader. Alright, GL create. Okay, GL create shader. GL vertex shader. Okay. See, one amazing thing about this is it returns an unsigned int. Interesting that GL create shader returns an unsigned int. I could have used an unsigned. I'm gonna stick with compiler figuring it out for me. That is, I'm just gonna create a vertex shader. I have this defined, and then GL vertex shader. Okay, GL shader source. This will be my vertex shader, and then add one, and then perhaps vertex shader source. Let me shade vertex shader source. I'm forcing my sync to write to use snake case because that way I have to modify the code for it and not rely completely on shader source. So you pass a pointer to vertex shader. Okay. GL shader source and then GL compile shader vertex shader. Check the shader compilers. Okay, shader IV. See, this is such C way of writing stuff. Check for shader compilers. Okay, I'm not gonna write that. And success. I'm using JK to go to the next line. That's why there is a sometimes I'll end up writing JK everywhere. So it says like success. What should I say? I have defined it. I can reuse it again maybe later. Char info log. Char. Why do you feel the need? Const expression int info log size 512. GL get shader IV. Okay, shader info log. Oh no, not that. GL get IV, shader IV, and then you pass in a shader. Okay, and shader is just vertex shader, I guess, and then GL compile status. And then I pointed to the success of do not declare style arrays, use a stud array instead. Hmm. I don't know. I did set a. I was not aware that it's gonna happen, but I'm gonna leave it. I'm gonna leave it like how it is. Like I don't think so. I can change that. It's asking me for a. It's asking me to write code in this way, so don't think so. That can change the. If success is non-zero, can I say? Hmm. Wow. See, this is great. If I changed it to be how it wants me to write it, it throws me a warning. Because I did it, I don't want any implicit conversions happening because this is something I hate. I absolutely hate implicit stuff. I want things to be explicit when I'm writing code. How do I deal with it? Let's see. Let's take a code action. And I don't think so. Oh, oh. Use random. Okay, and use variable. Compiler is. Oh my god. Clang expand macro. Okay, I think. Is it a macro? What does it expand to? Oh, okay. Nice. I mean, I don't care. GL is just glad. Why would they create a macro just to hide like 4 characters from a function call? Maybe that macro is doing something more than what I am already seeing, so I shouldn't judge it. But these abstractions low code. I can feel that somebody wrote code for it and decided to not touch it ever again. GL get shader info log, and I think here I have to pass in the vertex shader. What does it take though? What is the next argument? It takes buffer size, then it was info log size, and then null pointer. Wait, why size I and then length, and then success. Cannot initialize a parameter of type with the R value of type, and I think here it is saying wait a second. Cannot initialize a parameter of type glchar aka char pointer with an r value of type integer pointer. What am I doing wrong here? Get shader log info. Vertex shader and then info log size null and info log. Okay, info log. Uh, it's asking me. I passed in the wrong value. Alright, start out std. I should create a logger. Maybe I should use a logger something. Okay, I wanted to use a logger here. Std out. This thing I should minimize. Std out. What should be? Error shader vertex compilation failure. Okay. Compiling vertex shader failed. Why is there just an error message? Shouldn't it? Okay, info log is something I should also try to print. But it is like asking me. Is it info log just a string? Yep. See, what I absolutely like about this style of programming is that there is no wastage of memories like how I can think of. C is super efficient. And it makes sense that wherever you should be passing null pointer, it's telling me to pass a null pointer. Other than that, I am good with. I think mixing C and C++ code is absolutely fine. Okay, fragment shader. So this was the code for declaring vertex shader. Next, I think we should be going with fragment shader, and then auto fragment shader, and then get gl create shader, gl fragment shader. Yep. So this is a fragment. This will be the fragment shader which I'm trying to define here. Declaring fragment shader. Okay. GL shader source. Alright, GL shader source, and then you need to pass in. Thank you. Fragment shader, and then 1, and then address of source code. Fragment shader source, and then last would be success. Success is going to store the code of whether or not this process was successful. See, the idea of exceptions did not exist at that point when I guess this API was made, I believe. And since it has been working for so long, nobody bothered to change it, and which is completely fine, I believe. GL compile shader, alright. Compile shader and then fragment shader. Check for shader compilers. GL shader compile. Is it anything? Okay, shader IV. What is this? What? GL hit shader IV. Fragment shader. GL compile status and success. If success is okay, success being a zero value is a diabolical thing, but it's fine. I mean, we are talking in terms of error codes, so that's why I think the idea of an unsigned exists, because it can be zero. It cannot be negative. There are no negative error codes. That's why fragment shader is an unsigned. I mean, at least the no, not the fragment shader part, the success status. I think I can add okay, but again, see, this is why there was no reset of the success value, although we should reset it, because success will be reset anyways to 0. There is no need for it. Okay, if success is 0, GL get shader info log, then pass in fragment shader, and then the size info log size. Next was null pointer, and then last was what was it? Info log direct. Ah, we're not passing a copy. Okay, yeah, it makes sense. Absolutely, it makes sense. Mustard. See out. Okay, I did write a message before. I can just rewrite it again. Shader. Fragment shader failed, and you need to like print what was the error which caused it. Okay, now is the time to link those shaders. I absolutely love writing C++. I was like getting this JavaScript fatigue. Okay, check for shader compile errors. Shader compile errors is get shader. ID. Okay. GL get shader ID. Fragment shader. Wait, what am I doing? Auto. Shader program. This is your GL create program. Alright. What did it return? Unsigned int. GL unit. Nice. Let's start a timer of maybe 20 minutes. 30 minutes. The stream has been like so long. But it's fine. Shader program. GL create program. Now GL attach shader. Okay, this is actually good. Like, no link shaders. Can it be an info? Yeah. GL attach shader and then vertex shader. Wait. Shader program. I forgot it's not object oriented, it's like functional. Next is fragment shader, and then GL link program, and then your shader program. This is the abstraction that we should have started with. Okay, now need to check for lint errors. Oh, sorry, linking errors, which is like GL get program IV. Nice. Shader program, and then you have to like GL link status, which is ampersand. Okay, now I need to pass a pointer to this. If success happened. See, this is like invalid code in C++. Like you can't do that. You can do this in JavaScript and TypeScript, but no other language has a triple equal. And what were JavaScript makers smoking when they decided to have a triple equal? I have no idea. I don't care. Okay, GL program IV. Success GL get program info log. Alright, GL get info log, and then it will be shader program 512, and then null pointer, and then info log. Wait, why does it info log size. Wait, why am I getting an error? Did I not use oh, info log size? My mind was somewhere for a second. I was like thinking about something else. Okay, so where was I? GL get program info log. GL get program info log. Alright, so I also need to give an error, but see, this will fail though, isn't it? This is gonna fail. This is gonna fail. Linking failed. No, linking failed is enough. 512 null and an info log, and then info log. I think okay. I'm already printing the info log value. Okay, now you delete the shaders. This is good. Okay. Then okay. Wait. Interestingly, you don't delete shade. Okay, once you have compiled um, once once you've compiled and linked the shaders, you no longer need it. This is great, actually. I mean, nice, man. I mean, I feel like I'm playing with memory here. Vertex shader. Okay, fine, I guess. I mean, what do I say? You can delete. Set up vertex data and buffers and configure vertex attributes. Alright. Delete born, must delete compile the shaders. Got this from OpenGL. What am I saying? Let it be. Okay, now to set up the vertex data. Still haven't written code for vertex VAO, vertex array, What was it? Wow, yes, binding about vertex array object. I just remembered it. Float vertices. I can let's declare a const float. Let's say float array. If you ever see JK getting misprint, it's just me doing shift K instead of J, and that just fucks it. Wait, I could have just wait. Wow, why did I not? Oh my god, why did I never think about it? Oh no, oh no, oh no. I am getting an idea. I think somewhere I've defined. I know. No remap. J J K. I can just set shift. That is, you can never type JK and shift JK again. Will it work? I have no idea. Let's go! It works. Okay, nice. I never thought I would need this keybind. Hmm. Alright. Okay, let me open it. This is how fast Neovim is, by the way. To those who are complaining about VS Code, or not really complaining, but like really proud with these graphical programs. See how fast I can iterate. No other editor has that capability. Super fast. One sec. I'll be back. Where was I? Compiling vertex, declaring fragment shader. I was declaring the vertices now. Finally, I've reached to a point where I can do that. I'm not gonna. Okay, let me type that. So you have point 5f 0.0f. This is 0f. This is top right. Why is it a top right? Why a top right though? Wait. Xcaler. Need to open Xcaler, I guess. Print to taskbar. Okay. See, I. Give me a sec. Okay. What? Zen mode? Why can't I do all Z? Oh no, this is so bad. This is not going away. Should have gone though. Why can't I see Zen mode? Should have been able to. Okay, and let it be. So see, if you have something like, wait a minute, just let me check if I can have I don't want sloppiness. Accelerator is really good, by the way. See, if I have x and y axes, oh no, right, if this is my coordinate plane, this is 0 0, alright, then point 5 should be here, right? Top right, okay, makes sense. But how can a triangle have that? Like, I'm not able to understand. So maybe you can have a point around somewhere here. This will be your point 5. Man, I missed mathematics so much after it writing. This will be. Why are you not? What is wrong with this? What is wrong with this? Let it be. I shouldn't care much. This is not the point of. I mean, it's not gonna matter much, is what I can say. It's creating noise. Bottom, I think somewhere I wrote. It's gonna take it to the top, right? This is what I need to have. To have like some real estate is like what I wanted. Build. Nice. Vertices, I think it's saying is unused. Okay. Unsigned indices. Okay, then now you need to define the bottom right. Add a negative. Expected a. Yep, I think a comma is expected here. Okay. Negative is bottom right, of course, and then double negatives are bottom left, and then top left. Okay. Come on, man. No, what the hell? I cannot. This is frustrating. I have to let go of skeleton. Come here. Into taskbar. Yep. 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 and 3 1 top left, bottom right I was done with, and then bottom left. Next would be top left, and this should be, is it Y or yep. My brain is not braining, I don't know why. Maybe I'm just tired. What does it say? 5E12. Nice. Okay, unsigned indices. Note that we start from 0. First triangle and then second triangle. Why do you need 2 triangles? I thought we are rendering only 1 triangle, isn't it? I think you're showing me the you're gonna show me the code for. Okay, let me just write it down. Unsigned and what is indices? Indices. This says note that we start from 0. All right. Note we start from 0. 0 1 0. Oh my god. Oh, Neovim just gave up here. Uh, can you just not define it here? See, I tried formatting it and it did format, but just stay here. Don't be smart. 0 1 3, and then 1 2 and 3, and what they're saying is that first triangle. I don't know since when the second triangle was discussed, but it's fine. I trust you, author. I trust you with my soul. And I formatted it again. Alright. Is this an error? Yeah. I think I decided them to be not as warnings but errors. So that I know if I'm not leading. I don't want my software to break. That's why any fucking way. VBO. Wow. And EBO. Okay, I think it's trying to render the triangle. Oh, sorry. What do we have that? Rectangle. Not the triangle, but the rectangle. I didn't ask for a triangle. Oh, sorry, a rectangle yet. Come on. I'm almost done though. I'm almost there. Okay. GL gen vertex arrays. Wow. Alright. Then GL gen buffers. One, and then VBO vertex buffer object. Vertex. What was it? Vertex attribute object. Or was it? Wow was vertex attribute, right? I think so. Is it? Vertex array object. Okay. So this is wow. Alright. What now? GLGen buffers and then EBO. I'm not gonna do the. Okay, let's do it. Let's do it. Let's fucking do it, anyways. If it's asking me, I'm gonna do it. I think I should read about it. Then I should do it. Yep. Why leave something here? Okay, element buffer objects. This is one last thing we'd like to discuss when rendering vertices, and that is element buffer objects, abbreviated to EBO. To explain how element buffer objects work, it's best to give an example. Suppose we want to draw a rectangle instead of a triangle. Brother did not teach me completely yet how to draw a triangle. Bro decided it's better if I just show you how can you draw a rectangle. Isn't that great? That's great, my guy. That's very novel of you. That's like I respect that, but don't play with my soul. I'm like trying to do this for the past 4 hours. Okay, this is the amount of time it took for a noob web developer to write some C++ code. All right. Okay, I'm being a bad boy. This is not something. This is not something I should be screaming about. Element buffer object. All right. What I will do. Okay, so triangles. That is why triangles are so what I can say famous, because it's the triangles which are being rendered, right? Low poly triangles, I guess. This is great. I'm enjoying it because this is my uh, as a mathematician, this would just feel so good. So what it's saying is that CPP const float vertices should be an array and you can define this array by these coordinates rendered again. I know this is like insane stuff, but I get it. This was the triangle on the top right half, this is on the bottom left half, because you're gonna need this coordinate again, bottom right and bottom left. Yeah, I get it, this is a triangle. Okay, I'm not gonna spend enough time thinking. As you can see, there is some overlap of the vertices. Oh, let's go. I guess I gotta define it. I mean, I was like trying to ignore it, but I no longer can. That's just the beauty of life. See, so point 5 would be somewhere around here, I guess. Point 5. Okay, let's just do this thing. I'm just gonna say this is 1 unit distance and this will be 0.5, right? Yes, so this is 0.5 in the positive direction and this is 1.0 minus 0.5, then negative 1.0. This is 0.5 in the positive direction and this is 0 or 1.0 in the positive direction. This is 0 minus 0.5 in the negative direction, the y-axis, minus 1.0. Alright, this works, and of course you have origin there. Origin is 0. Alright, so 0.5 is gonna be here, and then 0.5 negative 0.5, so 0.5 negative 0.5 is bottom right. It's not, yep, see here, and then minus 0.5 and 0.5 is here. So this draws a triangle from here to here, then here to here, and then here to here. This is amazing. So this is one triangle which is gonna be rendered, and the other one will be, which is 0.5 x positive 0.5 and negative 0.5. This is like from here, and then bottom right, and it goes to negative 0.5, negative 0.5, which is going to be here, and the last negative 0.5, negative 0.5, and 0.5. This is great. This is actually good. This is the second part. The second part of the triangle. Nice. This is how you render a 2D square. Why do I keep getting here? What key binding am I pressing incorrectly? I have no idea. Alright, as you can see, there is some overlap on the vertices specified. I mean, of course there is some overlap on the vertices specified. Yes, that would be, this was declared twice, this one. So this I can say was declared twice. Okay, what about that? You specify bottom right and top left twice. Yes, there is an overhead of 50%. Exactly. Since the name rectangle could also be specified with only 4 vertices instead of 6, this could only get worse as soon as we have more complex models that have over 1,000 of triangles, where each will be large chunks that overlap. What, what would be a better solution to store? What would be a better solution is to store only the unique vertices and then specify the order at which we want to draw these vertices. Oh wow, in that case we would only have to store 4 vertices of the triangle and then just specify in which order we'd like to draw them. Wouldn't it be great if OpenGL provided us a feature like that? I mean, absolutely. Like tracing the perimeter. I'm tracing a line is like what essentially we're looking for. That would be great. Honestly, that would be really great. Thankfully, okay, why am I in light mode? I should be in dark mode. Thankfully, element buffer objects work exactly like that, and EBO is a buffer just like a vertex buffer object that stores indices that OpenGL uses to decide. Wait. Thankfully, element buffer objects work exactly like that, and EBO is just a buffer, just like a vertex buffer object that stores indices that OpenGL uses to decide what vertices to draw. This is so-called indexed drawing. This is exactly the solution to our problem. To get started, we first have to specify the unique vertices and to draw the indices. Then draw the indices also. Mega Chad, actually Mega Chad. I mean, this is great. This is insane. There is. Why is there a? Oh no. You can see that when using indices we only need 4 vertices instead of 6. Next we need to create the element buffer object. Alright, and similar to VBO we bind the EBO. Okay, let me write that down. Okay, I'm not gonna leave it there. Like, I spent so much time, and if the triangle doesn't render, I'm gonna lose my self. CPP. Okay. Left a back tick, is it? Yep. Okay. Similar to VBA, we bind the EBO and copy the indices into the buffer, and with GL buffer data, also just like the VB, we want to place those calls and a bind and an unbind call. Although this time we specify array buffer, element array buffer as a buffer type. But see, all of this is super. I mean, it's not like it's unintuitive. It's just that the API design is utterly trash. I'm sorry, I just had to say it. It's really bad. I mean, no way I'm gonna guess what element array buffer does. That's a Java 1. That's why they created C sharp, because they couldn't C sharp on C++ code bases. Alright, I got that. Got that part. Know that we're now drawing, know that now, okay. Note that we're now giving GL element array buffer as the buffer target. The last thing left to do is to replace the GL draw arrays call with the draw elements to indicate we want to render the triangles from an index buffer. When using draw elements GL draw elements, we're going to draw using indices provided in the element buffer object currently bound. Alright, I got that. That makes a lot of sense. GL bind buffer and then this CPP. See, of course I can use cloud or codex. (10 minutes) timer. 10 minutes. I need to end the stream in like 20 minutes. Okay, so the first argument specifies the mode we want to draw in. The first argument specifies the mode we want to draw in. GL triangles. Okay. Similar to GL draw arrays, the second argument is the count of the number of elements we'd like to draw. Second argument is how do you reach a first person shooter from drawing triangles to that? That's going to be insane. I mean, I don't know. I'm just lost here. It's gonna be really interesting the way you look at it, right? I wish I could just see somebody write a good code. I mean, somebody writing code that would actually work. Yeah, note that we're now giving the first argument specifies the node we want to try and. Okay, wait. The second argument is the count of the number of elements we'd like to draw, which is 6. 6? Is it 6? 1, 2, 3, 4, 5, 6. Okay. No, but it's not 6. It should be 4. 1, 2, 3, and 4. Okay, this I think is 6. Alright. Okay, elements is the length of the array. The length of the index array. This is like the number of index items and the index array. The second argument is the count or number of elements we'd like to draw. We specified 6 indices, so we want to draw 6 vertices in total. The third argument is the type of the indices, which is of type GL inside int. The last argument allows us to specify an offset in the EBO. Type. Okay, my bad. I missed some context. Like I'm losing my self right now. The first argument specifies the mode, second argument is the count, 6 indices, we want to draw 6 vertices, third argument is the type of the indices, which is like GL and ascending. The last argument allows us to specify an offset in the EBO. Or pass in an array, or pass in an index array, but that is when you're not using element buffer objects, but we are just going to leave it at 0. Alright, I mean, a lot of information to remember, and this is something super unintuitive. I don't know like when it will make sense, so I'm just gonna have some faith here, because this is the learning part. The GLO elements function takes its indices from the EBO currently bound to the target. Okay, for the array before target. These are targets. Got it. Better to call them targets instead of like macros or if defs. What do I call them? These are like hash defines. This means we have to bind the corresponding EBO each time we want to render the object which indices, which again is a bit cumbersome. So it just so happens that vertex array also keeps a track of element buffer object bindings. The last element buffer object that gets bound while a VO is bound is stored as the VO's element buffer object. Binding to a vow then also automatically bounds that EBO. The hell. Okay, so assuming, I mean, I get it. I see this thing is important. Like this is really important. I should take a note. This is the entire OpenGL. This is nice. This is actually nice that you have these strides, because see this, you have attribute pointer, you have vow object 1, vow object 2, VBO1, vertex buffer 1, vertex buffer 2, and this has like strides in between, although it also has strides but it has like 0 size. And if you define it using an EBO, what it says is that it's going to automatically bind here. The GL element function takes its indices from the EBO currently bound to the GL draw elements function. The GL draw elements function takes its indices from the EBO currently bound to the GL element array buffer target. This means that we have to bind the corresponding EBO each time we want to render an object which this means like we have to bind the corresponding EBO each time we want to render an object with indices, which again is a bit cumbersome. It just so happens that a vertex array object also keeps a track of element buffer object bindings. Happens. Okay, the last element. Okay, so alright, this is just information. Leave this at 0, right? So let me have it, I guess. I wish I could also paste images, but yeah, I mean, I can't do that in Neovim at least. There you go, Emacs. Kings out there screaming right now that I have to use Excalibur. At least we both are not using Obsidian. Above stores the GL bind buffer calls, where the target is this GL element array buffer. This also means it stores its unbind calls, so make sure you don't unbind the element array. Okay, not that I'm gonna completely remember doing it, but we got it, king. Shouldn't it be an underscore? Get it emphasized. Why is it let it be. So this just happens to be an important thing I need to worry about, I guess, that wow stores GL bind different calls, the target is etc etc. Alright. The resulting initialization and drawing code now looks something like this. Okay. Define a vertex array object, copy the vertex, alright. ABO, then we got the static draw, and then EBO, if I need static draw, attribute, then the vertex attribute pointer is float false. Okay. Alright, I mean it makes a little sense, but I'm gonna take it as just something that I need to do. CPPL. I don't know if it like identifies the syntax, but this is good progress. But still, like, I have not rendered a triangle, so running the program should now give an image as depicted as below. The left image should look familiar and the right image is the rectangle drawn in wireframe mode. The wireframe rectangle shows the rectangle indeed consists of two triangles. To draw the wireframe mode, I think nice. This is actually nice. If you can wireframe is such a nice word. Draw triangles in wireframe. We can configure how OpenGL draws this vertices by the GL polygon node. This first argument says that we want to apply it to the front and the back of triangles and segmentals is to draw them as lines. GL line. Any subsequent drawing calls will render the This is usually how you write graphics code. Something similar, I think P5 processing or P5JS does something similar. Alright, if you manage to draw, congratulations. Okay, I got this. Now, it's telling me, where was I? I declared EBO bind the vertex array objects first, then note bind the vertex bind the wow first, then bind and set vertex buffers. Okay. GL bind vertex array, GL bind vertex array is wow. Okay, I can close this. This is coming in between for no effing reason. I was mentioning that I was not going to talk about Obsidian, but I installed it because like I was giving up on note taking, but then Codex saved me by helping me create a config that would just work with Neovim. Alright, so wow. So see, first we generate vertex. One I think is the ID. GL bind vertex array. GL. Oh no. GL bind buffer. Why is it coming here? I have no idea. Windows is like super bad. I mean, who vibe coded it? I don't know. GL again. See, alt tab doesn't work the way I want it to work. GL array buffer. Too few arguments. Where does GL bind buffer? Yeah, yep. Okay, GL bind buffer. And the GL bind buffer data. GL buffer data, sorry. GL buffer data is a GL array buffer, and then size of vertices GL static draw. But toggle inlay hints, it's gonna help me a little, I guess. Target size buffer. Alright, so GL bind buffer, I know. Okay, the GL bind vertex array is the VO. Wow. But see, again, it is so misleading because inlay hints are telling me that I should pass in an array. But then again, VAO is not an array, it's actually an unsigned int. But it's like how it is interpreting. This is, I think, like what I was talking about, it being a leaky abstraction. I mean, the entire thing is leaking. There is nothing. Anyways, let's keep moving. We defined the VBO with GL static, and then GL bind buffer element array buffer. EBO target. Exactly. I mean, you should call it target. This is exactly how you should here's the definition. Yep. Alright, it's in glad. So that's why you should use a code LSP, because they're built to give you. Okay, I'm not gonna finish it, I guess, within like 3 minutes or something. So GL bind buffer, GL element array buffer, EBO, and then GL buffer data. GL buffer data, and next thing should be GL element array buffer. Oh no. GL element array buffer, and then what should be the next? Pointer size of vertices, is it? Size of indices. Yep. There's a pointer to GL static draw. Alright. GL vertex attribute pointer. Alright, then GL vertex point GL vertex. Why is it coming from glad? Why do I not have a GL vertex attribute pointer? Yes. And this should be 03 GL float. Okay. 0 is the enum type is like 3, and then normalized is GL float, GL false, 3. Okay, this is stride size of float. I can also pass in 0, but void pointer static cast void pointer not gonna pass in 0 and then void pointer. Like, that is weird, honestly. This is the best way I can do it. Okay. Then you define GL vertex attribute pointer. GL enable vertex active array. GL enable vertex attrib array GL. What does it really mean though? So I'm declared GL enable vertex array. And I get it. Note that this is allowed. The call to toggle the call the call to vertex array is to the VBO as the vertex attribute bound. What? The call to vertex attribute pointer registered VBO as the vertex attribute bound vertex buffer object, so afterwards we can safely unbind. Okay, I mean, I get it. I mean, see, I'm like getting impatient right now. This is the point of your code base where you are just, oh no, let me just get it done. Let me add it as a warning though. That way I remember to do what is required later. Remember, do not unbind the EBO while a VO is active, as the bound element object is stored on the wow. Keep the EBO bound. Okay. So this is like, to not do this is like what it is saying. Alright, I mean, I get it. Warned. This should be this should be commented. This should be comment. There should always be a comment. Let it be. I mean, I don't want to. If I'm formatting it, it is just taking me to a next line. What the hell? Let it be. This will be a comment. I mean, I guess you can unbind the VO afterwards, so that the VO calls won't accidentally modify this VO. But this really happens. Modifying other VOs requires a call to anyways, so we generally don't unbind vows, not VOs, when it's not necessary. Alright, I mean, again, something which is entirely not necessary, I believe, but I will store them as warnings because I am a good programmer. And comment this call to draw in wireframe polygons. Alright. Finally, I'm reaching it. I'm finally there. I'm almost there. Okay. I'll comment it out. I'll do it the bookish way. Alright. Process input. Alright. Render. RGB values is what I defined. GL clear. Color buffer. What? GL clear. What does it say? It says like this is render. These were like magic values, so it asks me to not pass in magic values directly. Process input. Input. Swap buffers. What was this about? Swap buffers, poll.io events. Poll.io. Alright, so drawing our first triangle. Mother of God. Drawing our first triangle. GL use buffer. GL use program. No, not gonna add like shader program, and then GL bind vertex array. Wow. seeing Seeing as we only have a single wow there is no need to bind it every time, but we will do so to keep things a bit more organized. Why? Why though? Like, I need reasons, you know. I don't need. That's the thing. I need reasons. And then no need to unbind it. Wait. GL draw 6. GL. This is this. GL draw arrays. GL triangles 0, 6, and this is not what we should do because we're not in that mode. GL draw elements GL triangles 6 and then GL unsigned and 0. Okay. What does it say? The null pointer where indices should not be a null pointer, isn't it? Should it be? It shouldn't be a null pointer. GL draw elements, right? I mean, if it's a macro call, mode is like GL triangles, that I get that, but like indices. Okay, we have like 6 length and then type is GL inside and then 0. Alright, no need to unbind it every time. Okay, this is like GL bind vertex array. Is it 0 or oh, okay. This is like warn. Okay, info. No need. No need to unbind it every time. Alright, so see, this is optional, but I'm gonna do it. I will do it. Like this will separate you from a bad developer. Alright. Deallocate all resources. This is great. GL delete vertex arrays. So see, this goes in the opposite order. This goes in the order in which they were defined, I guess. BAO pointer to BAO and then GL buffers, GL delete buffers. This is again VBO and then GL delete buff first one EBO element buffer object and then GL delete program shader program. Alright. Okay, this is it. This is how the moment of truth. Fuck, nothing is there. Oh my god. Why would you do this to me? Why would you do this to me? Why? Nothing is being drawn. Oh no. Oh no, oh no, I just wrote code for no reason. Is that so? Wait, let me save this code. Alright. Code for the triangle. Alright. Let me come on, I think it's caching it somewhere. Okay, source code seems to be correct. Come on. Alright, build. Again, nothing here. What am I doing wrong? What did I do incorrectly? Did I do anything which was not? What did I do? What did I do? Include ream and then lad. What did I do incorrectly? I see nothing here. Hello triangle is there, but like the source code doesn't tell me anything. Let me debug it. But this is like super discouraging. Like, what did I miss? Come on, GPT, I'm gonna let you. You have to like. Isn't a coding model? Alright. Why am I not seeing a triangle in my latest code? Come on, tell me something which I don't know. Shader not linked, vertex data not uploaded, vertex attribute not configured, not draw, call, never call. Shouldn't have missed it. Grabbing the exact numbers from too concrete correctness bug. Is it something to do with me using modern C++ syntax? Wait. Passes success as the length argument to GL. I'd have to make the Carry the passes success as the length. Main CPP line 76. Okay. That would have been like really a no mistake though. Fragment shader, where do you define the fragment shader? You are passing a null here, GL shader source. Huh. Okay, exactly. This is like null pointer. Come on. What was the second bug? Come on. Okay, got it. The fourth parameter is not a status output, it's an optional array of string lengths. At this point, success is the previous compiled is OpenGL user fragment shader source length. Okay, so they should null pointer main at 178. Okay, I was trying to be smart. 178. 3 uses size of indices a draw count expects the number of indices, not the number of bytes. Okay, I I can maybe does it say that I'm using it? Why did my LSP broke? What? Scenic build, scenic preset, uh, build debug. Oops. Scenic build. Okay, so this started working again, and then alright, it says like magic number const and number of number of vertices. No, it's not. It's not 6 actually. What was it? GL raw elements. What was it? But what did 6 mean? So the number of indices. Number of indices. So see, let me do this. Let me take this part and where it I can make it a const expression. And then I can pass number of indices here. Alright, now what? On more semantic point, your current geometry is not a single triangle. Okay. Let's see how it goes. So watch exec. Alright. Fuck you. I should not be cursing. Still, why am I not able to see it? Remove item. Okay. CMake. Preset. Build. Or it should be build debug. Alright, but like before that you have to run cmake preset debug build debug, then build. Let's go. I know it's not a triangle, I know, but this is beautiful. This is beautiful. This is beautiful. I am. I feel happy. Finally a square. Okay. The fact that you have to do so many things just to get this polygon. Where did I write poly? Yep. I need this. Uh, will it change anything? Nice. Increment. Okay. I feel so good. This is so satisfying. Finally, two triangles on my screen. Let's go. Oh my lord. Lord have mercy. Lord have mercy. I mean, see the amount of time it took just to render this effing triangle is insane. I mean, it's insane. It's insane, insane, insane. Wow. It's not a triangle, I know, but at least I got the squares working. That is great. I know it's not a triangle. I know it is not a triangle. This was great. This was a great experience. Hello, triangle. Hello, um, two triangles. This is such a great experience. I mean, again, I do need to do that. Let's go. I am happy. I'm just happy. This makes me so happy. This is the work. This is insane. This is insane. The amount of time it took was insane. And obviously, the next thing that you have to do is to post it on Twitter. Nice. I feel so happy. Alright, that is it. That should be the end of the stream. I hope somebody. I hope it was helpful to somebody. If it is not, I don't know. I enjoyed it. This was an experience having bugs, and then the codex helping me out figuring out those bugs is such a great thing. I mean, I think I have to read it again, maybe one more time, just to get it stamped on my head. But bug fix head to head to annoying bugs. All right. So see, I will also commit this code, maybe on a Neovim, sorry, on a GitHub repository. That way, maybe somebody who just wants to write code using Neovim can get some help. Maybe this was great. This was such an experience, and again, I will see you guys. I don't know. Maybe tomorrow, maybe the next Saturday, because usually